Hello and welcome to today's session on the differences between linear and quadratic relation. This is a very important concept, and therefore please listen carefully. Linear versus quadratic relation. Before we talk about exactly what linear and quadratic relations mean, I will start off by beginning with what a relation is. Relation, as the name says, it's basically a relationship. So we're looking at the relationship between two variables, x and y. As we know, x is our independent variable, and y is our dependent variable. So x could be anything, and y must depend on that. So let me give you an example. X could be study time, and y could be your grade. The reason that y depends on x is because your grade depends on your study time. The more that you study, the better your grade will be, well, hopefully. And therefore, this relation is looking at the relationship between these two variables. Now, within the relationship category, we have two subcategories, known as linear and quadratic. With linear, we need to know that linear is basically a straight line. So we're looking at the equation y is equal to mx plus b, where the m is your slope and the b is your y-intercept. And if you were to graph the linear, it would actually look something like this. It would be a straight line. It could be either this way, which is upward sloping. It could be this way, which is undefined. It could be a horizontal line, which means it's a slope of 0, or it could be something like this, which is a negative relationship. But one thing that's consistent amongst all of these is that a linear is basically a straight line, has the same slope throughout. Now looking at a quadratic, we see that it's a little different, because with a quadratic we're looking at things like a parabola. Therefore, there is no more straight line. We have something like a curved parabola, like a U shape, or it could be something like a N shape. And what's really different, again, between the linear and the quadratic, the first thing that you need to know is the slope. With linear, the slope is same, whereas with the parabola, or with the quadratic, the slope is changing. It's changing. That's one thing, that's the first point that you need to remember. The second point, it's different between the two, is the shape. So with a linear line, as we mentioned, it's a straight line, and it could be any way. It could be horizontal, vertical, or this way. And with a quadratic, it's a parabola. So that's the second difference. The third difference between them is basically their characteristics. And when I say characteristics, I mean that with a parabola, which is something like this, or it could be something like this, we have either a minimum, like this case, or we have a maximum. This is not apparent in linear, because with linear it's just a straight line, so there is no way that you can have a minimum or a maximum. And the fourth thing that you should also know is their domain and range. And you're probably wondering, what is domain, what is range? Well, if you remember, domain is basically looking at all the possibilities of x. So we're looking at all our x values. Let's say you have a parabola like this, and this is the x and this is the y. So you're looking at all the possible x values of the graph and seeing where the graph you're looking at all the possible x values and seeing where the graph what possible x values for the graph there would be throughout. And looking at the parabola, we see that actually it's from negative infinity up to positive infinity. These are all the possible x values for a parabola. The same goes for a straight line. With a straight line, again, we have all the possible x values, as you can see. And so this would also be from negative infinity up to positive infinity. Therefore, your domain does not really change between a linear and a quadratic, and therefore you would write it as the domain is equal to XER, which means that X is an element of all real numbers. And this is again the same for both of them, both linear and quadratic. Now let's look at the range. For the range, let's say you have a parabola like this. As we said, a parabola has a minimum or a maximum. In this case, we have a minimum, and this is our minimum point. Let's say it's 3. So the range looks at all the possible y values. So here we're looking at the minimum points in specific, and looking at what possible y values the graph can take on. So looking at this example here, we see that y can be actually any number, but it must be greater than or equal to 3. Because what happens is the lowest value that y can take is 3, and it cannot be lower than 3. Therefore, the 3 is our threshold, and that's why the y must be greater than or equal to 3. With a linear, we do not have something like this. So that's another difference between the two. With a linear, we just have a straight line, and the range would be just YER, because y can be any number. And again, that's another aspect that you should know about the differences of quadratic and linear. And finally, it's there one more thing that you would need to definitely know is their equation. So as we said, for a linear, the equation would be y is equal to mx plus b. For a quadratic, we have 3 different forms actually. For the quadratic, we have the standard form, we have the factored form, and finally we also have the vertex form. And all of these will be covered in a separate video, but you definitely need to know that their equations would be different for a linear and a quadratic. And one thing that I also want to mention is the fact that for linear, the exponent on the x is always a 1, or the exponent on the independent variable is always a 1. For a quadratic, the exponent is always a 2. So anytime you see an equation like this, you should automatically look at the exponent and say that, oh, this is a 2 here, therefore it's quadratic. Thank you for listening, and in this session we talked about the differences between linear and quadratic. Specifically, we looked at the equation, the fact that they have different slopes, they have different shape, and so one of them is a parabola, the other one is a straight line. They have different characteristics. So with a parabola, we have the minimum or a maximum, whereas with the linear line, we do not have any of that. And finally, the domain and the range. So going back to here, we see that the domain and the range, the domain is actually the same for both of them. It's XER, but the range is a little different. For the parabola, we have some limits and that we need to look at. Specifically, we need to look at the maximum or the minimum point and base our range on that. For linear, it's just YER, because the straight line goes throughout the whole graph. So these are things that you should definitely keep in mind when you're doing these questions. In the next video, I will be putting a few examples that we can do together to better understand this concept. Thank you.